pretty quick notes that we're going to have. This is day 28. We're doing confidence intervals for a difference of two proportions. And we've kind of had a pattern. You know, we did confidence, or first we did a test for a difference of means, then a confidence interval for a difference of means, then we did matched pairs. Last time we got together we did a z-test for the difference in two proportions, and now we're doing a confidence interval for that. And basically for everything we did the test and the confidence interval. So the test over this will be tests, okay, and confidence intervals. All right, so we've got a drug that's hailed for treating heart attacks. This is just where it was at. In a study of 12,562 patients in 28 countries, half of the subjects were randomly assigned to a new drug called Plavix, and the other half were given the standard treatment for patients who suffered a minor heart attack. So two treatments, Plavix, standard treatment. So it's like we're comparing a new and an old treatment, which is typically what they do in medicine. So just 9.3% of those receiving Plavix had further complications, compared to 11.5% of those receiving the standard treatment. Use a 90% confidence interval to estimate the true reduction in the proportion of patients with further complications. Does your interval give evidence that Plavix is more effective? So we could do a test. We could do a test to see if Plavix is more effective, but this confidence interval will also allow us to come to a conclusion as well. So, first thing I'm going to do, we want to write down our proportions. This is going to be a two-sample z-test for a difference of proportions, P1 minus P2. That's what we're going to be doing here. Not a test, sorry. A two-sample z-interval for P1 minus P2 at 90% confidence level. Okay, so we have a 90% confidence level. A 90% confidence level is similar to a alpha of 5.05, 5%. Why is a 90% confidence level? Subtract it from 1, take 90%, 0.9, take it away from 1, divide by 2. That is the alpha level that goes with it. If you think 90% confident, we're 10% not confident, but that 10% is split up above and below. So it would be an alpha of 0.05 that goes with this. All right, and also the thing to remember is the confidence interval is always two-sided, above and below. That's why you have the plus and minus in the confidence interval. And a test is usually one-sided unless it's a not equal to alternative hypothesis. So let's just write down our information first. We've got Plavix. What is the proportion p hat of Plavix? We'll use P as our subscript. What was that? 0.093. Okay. And p hat of, what do we want to call it? Standard, S for standard treatment. 0.115. Okay, and these represent the percent or proportion that had what? Further complications. So the higher percent means more complications after having their heart attack. What are complications? More issues, more things to deal with. Maybe you kept having heart attack symptoms, okay? All right, so what's N for the Plavix? How many were in the Plavix? How did you get 6,200? Thank you. Divided. That was, yes, you're absolutely right. Divided it by 2. Okay, they say 12,562 patients in 28 countries, half the subjects, so you just divide it by 2. So they are both the same sample size. All right, so does there appear to be a difference? What would be the p hat of Plavix Now, we have to really think about this. Do we want to do Plavix minus standard or standard minus Plavix?
Let's do standard minus
Well,
Plavix.
It-
It says the
No, you
true
should do Plavix
reduction,
minus standard.
so that's
it
kind
asks
of old
if
minus new.
Plavix is more effective.
So it asks if Plavix is more, well, you know what, it doesn't matter how you subtract it, it's the greater than or less than that tells you if it's more effective.
If Plavix is more effective, it would be less than standard because
You're,
you want a smaller
Yeah.
percentage. Yeah.
very good, and that's the kind of thing you have to wrap your brain around as you're working on these. You have to say, okay, what does it mean if Plavix is better? It means this percent will be smaller than this one. I mean, it doesn't matter how you subtract them. It honestly doesn't. The reasoning part you have to think about regardless. So you want to do Plavix minus standard or Okay. So Plavix minus standard is equal to, let's find the difference. So Plavix minus standard, it's negative 0.09. Oh, I got to turn it on. The observed difference is negative 0.0022. No, zero.
Negative 0.02.
Yeah, 0.22. Thank you. I'll get that right eventually. Okay.
That calculator was how it
Yeah.
happened.
It gave it to me in scientific notation.
But there's no decimals. It has to be smaller than 10.
Yeah, it's just weird. Okay, so does there appear to be a difference? Does Plavix appear to be better? Because the difference is negative, okay, if Plavix is actually better, this percent is less. So, step one, at first glance, nope. How did I start wrong? What should I say in a confidence interval?
Oh, wow. I don't remember you said that.
I am trying to estimate, yep. So the step one statement, I'm trying to estimate the true reduction in the proportion of patients with further complications. My best guess is negative 0.022. We are most likely incorrect due to randomization variability, so I will create a 90% two proportion Z interval for the difference. Okay, so what do I need to do next? Check my conditions. Check my conditions. What's the first condition?
Can you make your hypothesis?
Oh, yep, nope, because we're doing a confidence interval. We don't need to do a hypothesis. We could do a hypothesis. If we were doing a hypothesis test, the null hypothesis would be that observed difference between Plavix and the standard treatment, not observed, the true, is equal to 0. In other words, they're both equally effective. And the alternative would be that difference is less than 0. Because if Plavix is indeed better, its percent is smaller than the percent of people who took the standard treatment that have complications. That's the thinking part of it. So now we can check our conditions. There's only 2 in an experiment. Were the treatments assigned randomly? Yes, so treatments were assigned at random. And we have to see if the sample size is large enough for the other one. If you accidentally tested the 10% condition, that would probably be okay. You'd say 12,562 patients, or actually 6,281 is less than 10% of all people taking Plavix and the regular and the standard treatment. Okay, but all we really have to check is large sample size. And so we would have to take our N times P and N times Q for each set. Since all of these values are greater than 10, we're going to move on to our calculations. So our confidence interval is our test statistic, which is the observed difference in the proportions, plus and minus our Z critical value. What is the Z critical value for 90%? So you'd have to go to, inverse norm and 0.95 and that is 1.645, so 1.645. Remember the Z ones were, you did have them memorized. You need to go back and remember them again, or you can do inverse norm 0.95. All right, and then the standard error of my statistics. So this is, now, it's not just p hat and q hat. Well, actually it is here. We just use the sample values for the two. It's not pooled at all. So we're just going to use the p hat 0.093 times q hat 907 divided by 6281 plus 0.115 times 0.885 divided by 6281. Now, this I could just write this down. I could write this down. This is my formula. I can let my calculator do the rest of the work for me if I want to. Because this observed difference was negative 0.022. And so I can go to stat, tests. I know we're not doing a test, but notice there's a Z interval. You can do a Z interval. You could do a T interval, a two-sample Z interval. We want to do a two-proportion Z interval. That's what we're doing. Two-proportion Z interval. Hit enter. So our X sub 1 was, how many were in that first group? We actually figured it out here. 584. And the number, total number in that first group, 6281. And in the second group, we figured all of these out when we did the P hat, P and Q, N times P, N times Q. So 722 and 6281. And I want my confidence level 90% and calculate it. So it gives me negative 0.031 to negative 0.013. Okay, very good. So what can we conclude? Is Plavix better?
Yes.
Why?
Because the interval's completely negative.
Okay, since the interval is completely negative, we can conclude that Plavix is better. That's basically the conclusion. We should also make some type of statement like our step 4 statement. I am 90% confident that the interval from basically you can say, well, negative 3.1% to negative 1.3% captures the true mean,
True proportion.
true proportion,
For true reduction.
yeah, true reduction in the proportion with complications. So I am 90% confident that the interval from negative 3.1% to negative 1.3% captures the true reduction in the proportion with complications. Since it is all negative, we can say that Plavix is better. If 0 were in the interval, if we went back and looked at our hypotheses, even though we didn't have to write them, the fact that 0 would be in there, 0 means there's no difference in the effectiveness. So if 0's in your interval in a 2-sample test, it means there is a chance that the treatments are not different from each other at all. All right, so before you have time to do your homework, we're going to do an AP question.